Greetings, everyone. My name is Queen. I'm an architect from Vietnam with nearly 10 years of experience in architectural design and urban housing. Today, I'm pleased to share with you our research conducted in collaboration with my co-author and supervisor, Dr. Bayman, a lecturer at Griffith University in Australia. Our study focuses on enhancing thermal comfort in Vietnamese chill houses, a dominant and challenging urban housing typology, by exploring the impact of various window opening schedule for utilizing natural ventilation. This study aims to provide a comprehensive and practical perspective for architects, urban planners, and policymakers to implement energy-efficient building strategies suitable for tropical climates and mitigate climate change impacts in Global South. To begin, I would like to provide some background on our research. It is projected that by 2050, over 70% of the global population will live in the urban areas. This inevitable increase in urban building density significantly influences the quality of indoor environments. Besides, people spend more than 80% of their time indoors, while indoor air quality not only impacts on occupant well-being, but also building energy consumption. However, nowadays, for example, in tropical climates, to maintain acceptable indoor environmental conditions, occupants usually rely on air conditioning systems and artificial lighting that are two of the largest contributors to global energy consumption, accounted for around 70% of final energy use worldwide. Besides, what research has shown that the global climate warming can have a serious threat to humans in warm climate, especially those in low-income countries. Vietnam is one of Southeast Asia developing countries with a tropical climate that enduring many impacts by climate change, particularly in energy and urban development. Extreme weather such as unpredictable typhoons, droughts, and floods are increasing rapidly. That has not only affected thousands of people's lives, but also impacted on the country's general economy. Regarding the urban development, Vietnam has around 888 cities, with Hanoi and Ho Chi Minh are the two largest cities. From 2014 to 2049, Vietnam's urban population is estimated to increase nearly 30 million people, accounting for nearly 60% of the total population. As a result, climate action and sustainable urban development are key objectives for Vietnam, the future plans. Such growth in urban population has led to a demand for more land to construct residential houses. From 2005 to 2013, the area of constructed dwellings in Vietnam rose by more than 100% annually. The rapid urbanization has led to an irregular development in urban design or unsustainable construction of residential buildings in big cities. Among residential types, the chill houses or street houses comprises 94.1% of total urban dwellings, indicating its clear potential to reduce total energy consumption in urban areas. After 1986, traditional chill houses emerged as the popular architectural style in urban regions due to their cost-effective construction, accommodating the rapid pace of urbanization. The defining characteristic of traditional houses include a lengthy and narrow configuration, typically comprising 1 or 2 stories, as well as internal voids designed to enhance natural light and ventilation. However, contemporary chill houses have undergone a transformation towards reduced lengths with an increased number of stories, a development adaptable to the densely populated urban environment. Based on location, Chill houses are divided into two types. The first one is situated on the main traffic roads with at least one or two lanes, while the second type is found in the narrow alleys. Because of outdoor access limited to only one side, chill houses usually have a poor natural ventilation, especially in the back rooms away from windows, which often rely on air conditioning for thermal comfort. The contemporary chill house typically has from 3 to 4 meters in width and around 15 to 20 meters in length. It's had from 3 to 5 stories, with each floor average 3.5 meters in height. The building density is extremely high, exceeding 90%. And the main chill house envelope materials will include brick walls, concrete roof or metal roof, and the single glazed transparent windows with wood or aluminum frame. This table compares the advantages and disadvantages of chill houses. Regarding the advantage, chill houses are free to design build, easy for motorbike parking inside, and they have a higher real estate value compared to apartment and private owner in the long term. However, the main problem of chill houses are the poor microclimate due to high density construction and high heat absorption. Almost 80% of chill houses in Vietnam were designed and constructed by homeowners and builders, often without consideration on energy efficiency. Therefore, almost urban chill houses rely on air conditioners for enhanced indoor thermal comfort. Besides, diverse design, function, and access points make it challenging to manage by government. The case study in our research lies on an early street with 2 meters in width. It was constructed in 2018 in Ho Chi Minh City. In general, a typical early chill house has a living room and kitchen on level 1, and 2 bedrooms with a shared toilet on each floor above. The front bedroom will connect more to the outdoors with the exterior window, while the rear bedrooms usually do not have windows or limited connect to outdoor because of neighboring obstacles. Almost contemporary chill houses do not have internal courtyard, except the light well in the middle of the building. The importance of open or closed windows in enhancing buildings' thermal comfort has been highlighted in scholarship. Opening windows are necessary for natural ventilation and improving airflow inside the buildings. The question of our study is separated into two parts. The first one, in the context of the early chill house, how feasible is it for the building to depend on natural ventilation without using air conditioning? The second one is how does window open behavior improve thermal comfort without mechanical ventilation in a typical modern chill house? There are 6 options of exterior window open schemes that will be analyzed in this research. The first one is a full day open. The second one is a full day close. The third one is a nighttime open and daytime close. Option 4 will be fully open but closed from 11 a.m. to 4 p.m., which are the hottest times in a day. Option 5 has the open in daytime and closed in nighttime. The last option will be open when room temperature are higher than 29 degrees C. Building simulation has been more popular to predict building performance by numerous different and complicated conditions while saving time and resources compared to experimental methods. The ISB energy simulation software will be used to simulate and evaluate the thermal comfort of the building among 6 different options of window open schedule. Building properties will be set up with the same data among options, except bedroom exterior window open schedule. Ho Chi Minh City has a tropical climate with high temperatures and high humidity throughout the whole year. There are two main seasons, namely the rainy season and the dry season. The average temperature is around 27 degrees C, with the maximum one can reach up to 40 degrees C. There are two popular thermal comfort predicting models, namely the rational model and the adaptive model. Numerous field studies across various climate zones have consistently demonstrated that occupants of naturally ventilated units have greater thermal adaptability than those in air-conditioned environments. Occupants' behavior to adapt thermal comfort include changing clothes, opening or closing windows, moving to other rooms, changing the activity status, or using fan, air conditioning. A new approach for free control spaces, namely the adaptive thermal comfort model, was applied and developed over 30 years. In this research, the adaptive comfort model from ASHRAE 55 standard will be applied to define the acceptable operating temperature range. In detail, the prevailing mean outdoor air temperature will be a key input, which is calculated by a simple average as equation 1, with the weighted running mean is recommended as 0.9 for hot humid climates. The equation 2 are used to define the 80% of comfort acceptability range based on the values of prevailing mean outdoor temperatures. In part 3, we would like to share some results from simulation process. Firstly, is the thermal comfort performance of front bedroom on second floor under 6 different window opening schedule. It's evident that none of the configuration achieve the thermal comfort through the entire year. Among our options, scheme 1, 3, and 4 demonstrated the highest thermal comfort performance, maintaining acceptable thermal condition for more than 70% of the year. In contrast, option 2, where window remained closed both day and night, had the poorest performance with over 60% of day falling outside the thermal comfort range. Option 4 emerged as the most effective scheme, maintaining thermal comfort condition for nearly 80% of the year. Its performance highlights the significance of nighttime ventilation, as option 1, 3, and 4, with each incorporating nighttime window opening that demonstrates superior thermal performance. Conversely, option 5, which involves closing window at night and opening them only during the day, result in the relative poor thermal comfort, similar to option 2. Regarding the rear bedroom on second floor, the trend observed in this room closely mirrors that of front bedroom. Option 3 and 4 again show the best performance in maintaining acceptable thermal conditions, while option 2 represents the least favorable case. Interestingly, although option 2 still be the lowest comfort performance, its percentage of comfort day is slightly higher than the front bedroom by 10%. The difference may be attributed to the location of bedroom 2 at the rear of the building, which limits its exposure to direct solar gains through exterior windows compared to front-facing bedrooms. In the living room and kitchen on the first floor, the differences among the window opening scheme are minimal. For example, that the worst case option 2 with the window closed all day and the best performing scheme option 4. So the similar results with the differences of less than 10%. Overall, the influence of exterior window opening strategies on thermal comfort in level 1, living room and kitchen, is relatively insignificant. Furthermore, these two rooms demonstrate the highest thermal comfort performance compared to the rooms located on the upper floors. In conclusion, nighttime window opening is the best option for natural ventilation during the cooler months from January to March and August to December, where bedroom operating temperature remain below 29 degrees C. During the hottest month from March to July, Natural ventilation alone is often not enough to maintain thermal comfort. Besides, closing windows during peak hours from 11 a.m. to 4 p.m. and using ceiling or standing fans can increase thermal comfort significantly. Future design concept for chill houses should propose more open indoor spaces instead of closed space to enhance air movement and cross ventilation. The architectural solutions such as overhangs or protective elements like louver screens can be integrated into the building envelope. The features can protect openings from rain, enhance privacy, and increase the benefits of nighttime ventilation. And with that, we come to the end of the presentation. Thank you for the time and attention. We hope our research have provided a clear overview of current residential housing and urban development in Vietnam. If you have any questions or would like to discuss further, please feel free to reach out. Thank you.